Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at applications of solving right triangles. So in the last video we talked about how to solve right triangles, and now we're going to look at questions where they're more like word problems, and you'll be asked to find some missing value, and you're going to need to solve right triangles to do that. So a typical question that you might see would be something like this one, which talks about the angle of elevation. So a cat named Fluffy is stuck in a tree. Sheldon is standing 20 meters from the base of the tree, and the angle of elevation from him to Fluffy is 25 degrees. How high up the tree is Fluffy? So my first step in solving this is to draw the right triangle. I have to come up with that right triangle. Now, those of you that are artistic, you can draw cats and trees and all sorts of things. I am not artistic, so I'm just going to be sticking with lines and dots because that's about all I can manage. So we've got a tree. We've got a cat, Fluffy, up in our tree. And 20 meters from the base of the tree, we have Sheldon. We're told the angle of elevation. So the angle of elevation is defined as the angle formed by the line of sight and the horizontal. So here's our line of sight to the cat. Oops. There's Sheldon, there's the cat. We're not going to worry about the fact that there is some height on Sheldon, and we're talking about his angle of elevation from his eyes. We're not going to get into those details because in these problems that you're going to see, they typically don't. So we've got a person here looking at a cat here, and we know this angle of elevation is 25 degrees. So this is called our angle of elevation, which most people understand. The question asks us to find how high up the tree Fluffy is, so we want to find this height here, which I'll call h. So now we've got our right triangle. Here's our right triangle, our right angle. So we have a right triangle, and we're going to solve for h. We define what our sides are in relation to the angle that we're given to determine what trig function we're going to use. So in terms of this angle, this side is the opposite side. This side is the adjacent side. We don't care about the hypotenuse, and the trig function that uses the opposite and the adjacent sides is the tangent function. So tangent of an angle is the ratio of the side opposite the angle to the side adjacent to the angle. So we plug in what we know. The tangent of 25 degrees will equal the opposite, which is h. We don't know that. The adjacent is 20. To solve for h, I multiply both sides by 20. And then in order to calculate that, I plug it into my calculator, and you should get a value of 9.3 meters. So that's how high the cat is in the tree from Sheldon's eyes. Okay, let's take a look at another example. Another typical right triangle problem that you might see deals with angle of depression, and many people define angle of depression incorrectly. So I want to do an example to show you how to define angle of depression. So we've got Patty climbs to the top of a hill and is able to see her sister Selma below. The angle of depression is 30 degrees. If the hill is 100 meters high, how far is Selma from the base of the hill? So very similar to our last question, we've got someone up here, we've got someone down here. So this is going to represent the hill. Here's our horizontal distance, and there's our line of sight. So let's figure out what we know, and this is going to be our right angle right here. So we've got Patty here, and you can get very creative with your drawing if you choose. Selma is there. So we know that the hill is 100 meters high. So we've got that distance. We know the angle of depression is 30 degrees. The problem that a lot of students have is they define this as the angle of depression. It is not. The angle of elevation and the angle of depression are actually the same. They're defined as the angle formed by the line of sight with the horizontal. So the horizontal is here. Here's our line of sight. So the angle formed by the horizontal and the line of sight is the angle of depression. Not this. Here's our angle of elevation. It's formed by the horizontal and the line of sight. And there's some geometry proofs that will tell you that these two angles are equivalent. It gets into some geometry that I don't want to get into. I'm talking about interior and exterior vertical angles. But what's important is to understand that the angle of depression will be the same as the angle of elevation. So this we know is 30 degrees. Therefore, this is also 30 degrees. Now that we've got our triangle, we know a side, we know an angle, we're asked to find what's the horizontal distance, how far is Selma from the base of the hill. So we want to find this distance, which we can call A or X or whatever you'd like to call it. We're going to solve for that. In terms of this angle, this is the side opposite. This is the side adjacent. So again, just like the last problem, we're going to use our tangent function. So the tangent of 30 degrees will be equal to the opposite side, which is 100, divided by the adjacent side, which is A. I'm going to multiply both sides by A. Divide by tangent of 30. You can go straight from here to here. I just didn't want to lose anybody. And when you divide 100 by tangent of 30 degrees, you should get a value of 173.2. And we're talking about meters. So that's how far Selma is from the base of the hill. In this example here, we have an isosceles trapezoid. A trapezoid has 4 sides and only 2 sides are parallel. So these 2 sides are parallel and our dimensions are given. An isosceles trapezoid is one in which these 2 sides are equal. So the non-parallel sides are equal and therefore these angles are equal. And in this example, we're asked to find angle beta. So in this example, we don't have an obvious right triangle. So we have to determine where our right triangle is. So in order to do that, I'm going to draw a line straight up from the corners here so that they are perpendicular with our parallel line here. And because it's an isosceles trapezoid, these 2 triangles are identical. They're the same angles, the same lengths, and so on. And I'm going to just deal with the one triangle. So these questions can be very challenging. It's not obvious where the right triangle is, so you have to kind of play around with them sometimes. Now, in order to solve a right triangle, we need 2 pieces of information. What do we know? We know this perpendicular distance is 40 millimeters. We're asked to find this angle, but we need one other piece of information. So we're going to go back to this drawing. Because it's an isosceles trapezoid, this length here is going to be equivalent to this length here. In order to find that, I take the difference, I subtract 30 millimeters from 50 millimeters, and that gives me 20 millimeters. So this plus this have to be 20 millimeters, which means that is 10 millimeters. Now I have enough information to find that angle. In terms of this angle, this is the side opposite. This is the adjacent side. So the trig function that I'm going to use is the tangent function. So the tangent of beta will be equal to the opposite, which is 40 millimeters, over the adjacent side, which is 10. I can simplify that to equal 4. So beta will be equal to the inverse tan of 40 over 10, which is 4. And beta will be equal to 76 degrees. So you might see questions very similar to this. Our last example has 10 equally spaced holes on a circle that has a diameter of 40 centimeters. And the question asks us to find the straight line length between adjacent holes. So often students will simply take the circumference and divide by 10. In doing that, you're finding what's called the arc length, that curved length, but the question wants to find the straight line distance. So that is called chord length. And again, we don't have a triangle here. We don't have a right triangle, so we have to figure out how to get that. What I'm going to do is draw the radius to the center of the circle from each of those 2 points. So I know that the radius is 20 centimeters. So I now have a triangle, and I'm just going to draw that triangle a little bit shifted over. So we've got 20 centimeters there and 20 centimeters there. Because those lengths are equal, it's actually an isosceles triangle, and there's certain characteristics about an isosceles triangle that are unique. That you can't apply these properties to other triangles, but because these because these sides are equal, then these angles are equal, and I can split this isosceles triangle into 2 equal right triangles. So they're identical. I'm going to just deal with this. I'm just going to take this triangle here. And that's the right triangle I'm going to solve. But I need more information. I'm looking to find this distance here. In this triangle, if I find this, I'm going to call it x, all I need to do is double it to get that distance d. But I need more information about this triangle. So what I'm going to do is look at where that information can come from. I don't know this distance here. Do I know the angle? Not yet, but I do know that there are 10 equally distant circles. So if we take 360 degrees and divide by 10, this angle here would be 36 degrees. And it's going to be 10 of them around this whole circle. So if this angle here is 36 degrees, and this right triangle is bisecting that angle, then I know that this angle here is 18 degrees. Now I have enough information to solve this right triangle. This is the side opposite. This is the hypotenuse. So I'm going to use my sine function. So the sine of 18 degrees will equal the opposite side, which is x, over the hypotenuse of 20. So x will equal 20 times the sine of 18 degrees. And that value is 6.2 centimeters. Therefore, my distance will be 2 times 6.2, or 12.4 centimeters. So these right triangle application problems are not easy. Some of them are easier than others, but certainly when you get into ones like this where you don't even see a triangle, let alone a right triangle, it can be very challenging. So that's why I wanted to include some of these types so you can see how I approach it. Take care, and we'll see you on the next video.